Okay, kids, let's solve a simple series circuit armed with nothing but Kirchhoff's laws and Ohm's law. In a series circuit, your resistors come one after another after another. The most important feature to realize about that is when the current flows from the battery, the same current will flow through resistor 1, 2, and 3. Each time the resistors will drop the voltage proportional to their own resistance. So let's first find the complete resistance, total resistance in this circuit. Because we're dealing with a series circuit, the total resistance is the sum of the three resistor values. In this case, 100 ohms, 200 ohms, and 300 ohms, the sum there being 600 ohms. Now for the total current in the circuit. Current, recall, is given in Ohm's law, V equals IR. Solving for I, it's going to be voltage over resistance. Total voltage of my circuit, 1.5. Total resistance of my circuit, 600 ohms. 1.5 volts divided by 600 ohms is 0.0025 amps. What now is the voltage drop across each resistor? So for the entire circuit, the total voltage drop is going to be that 1.5 volts. Each resistor we go across will obey Ohm's law. So the voltage drop at resistor 1 is the current going through resistor 1 times the value of resistor 1. The current we saw for earlier, 0.0025 amps. The value of resistor 1, 100 ohms. .0025 amps times 100 ohms. It's going to give me 0.25 volts. The voltage drop across resistor 2 half a volt. Voltage drop across resistor 3. .75 volts. Now, we stated earlier that the total voltage drop needs to be 1.5 volts. If I sum up these three numbers that I got, 0.25 volts, 0.5, and 0.75 volts, I get a total of 1.5 volts, meaning that the answer checks out. Simple series circuit. It's a mouthful, but there it is, completely solved.